Let's continue our discussion on quadratics, and let's talk about some techniques to use right off the bat. Right? So if I gave you this particular function, how about f of x equals x squared plus 6x, and we set that equal to 0. One thing you should always do whenever you're factoring, the first step is to pull out common terms. What this does, it'll take your equation and make it smaller, and usually that makes it much easier to work with. So for example, in this case, x squared plus 6x, if you notice, they both have x's in them. This has one x in it, this has two x's in it. So let's factor an x out, and then what we're going to be left with is an x plus 6. And now what we have here are, again, two terms multiplied together to give us 0. So we can solve this by saying, all right, when is x plus 6 going to be equal to 0? That's when x equals minus 6. When is this term going to be 0? Well, it's already solved. All right. So we get two solutions of x equals 0 and x equals minus 6. Another example might be something which looks like this. How about f of x equals 2x squared plus 8x minus 90. All right, and again, let's set this equal to 0. If you notice, they all have even coefficients in front of them. So why don't we factor a 2 out, and when we do, and again, remember when you factor something out, you're dividing it. I'll get an x squared, a 4x, and a minus 45. And now we're back into one of those ones we just saw a minute ago, to where I need two numbers that multiply together to give me a negative 45 and add together to give me a positive 4. So in this case, 45 factors into 1 and 45. Let's see, 3 and 15, 9 and 5, and I think that's it. And I think we can work with this one right here. Right? Because if you don't forget to carry that 2 along, that factors into, see, I need an x and an x. I need, again, because this 45 is negative, I need one to be positive and one to be negative. And I need to have the bigger one be positive, since it's a positive 4x. So that can be a positive 9 and a negative 5. Right? And then this is my factorization for my original problem. So remember, first thing you should always do, pull out common terms. You don't have to do this, but trust me, it will make your life much easier. Well, if we go back to the original formula for a quadratic, remember, it's a polynomial. That means the biggest exponent is 2, and they're all integer polynomials as well. Okay. So what we can do now is, no matter what we're given, we have a certain formula that we can use which will always solve a quadratic for us, and it's got the crazy name of the quadratic formula. Right. And the two things you need to have in order to have this quadratic formula work for you is you have to have a quadratic, and your quadratic has to be set equal to 0. So this formula, again, only works if you have a quadratic set equal to 0. Right? If you get that, then here are your two answers. Right? It's going to be negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a, right? Where a comes from the number or the coefficient in front of the x squared, b comes from the coefficient in front of the x, and c is just whatever constant we have. Right? So if we go back to this one, let's say x squared minus 5x, how about minus 6? Right? How does this one factor? Right? This actually factors into x minus 6 times x plus 1, where I could solve this to get x equals 6, and I could solve this one to get x equals minus 1. Right? So we know that those are my two solutions. Let's try the quadratic formula to make sure that we get the exact same thing. So the way we can set it up is, it'll be negative b, and in this case, there's my b value, it's negative 5, so I'll have a negative 5, and then it's plus or minus the square root of b squared, so again I've got this negative 5, and I'll square it, and then that's minus 4 times a, which is the number in front of the x squared, and remember if there's no number there, it's assumed to be 1, right? And then it's times c, which is the coefficient, which in this case gives me a minus 6. Right? And then that's all over 2 times a, and remember in this case, a is 1. So here's how it simplifies. The negative 5 becomes a positive 5, and then inside my square root, negative 5 squared gives me a 25, and then negative 4 times 1 times 6 gives me a positive 24, which makes this just a square root of 49. And of course, the square root of 49 is just 7. Right? So that leads me to two answers, 5 plus 7 over 2 and 5 minus 7 over 2. Of course, 5 plus 7 over 2 is just 12 over 2, and 12 over 2, of course, is the same thing as 6. Right? And then 5 minus 7 over 2 is just negative 2 over 2, and negative 2 over 2 gives me the same thing as minus 1. So we had two ways to solve this. Now the factoring way is nice, but sometimes you have something which does not factor very easily at all. Whenever that's the case, you can always just hop over here to your quadratic formula, and it will solve the problem for you. So let's take a look at another one. Here's one. F of x equals x squared plus 4x minus 5. Okay. Let's see, does this one factor? I can have an x, I can have an x, then how about plus 5 and minus 1? Yeah, that factors. So I get x equals 1 and x equals negative 5 as my two solutions. Again, let's verify that with the quadratic formula, where here again a, the number in front of the x squared, is a 1, b is a positive 4, and c is a negative 5. So the two solutions here would be negative b, so that'll be a negative 4, plus or minus the square root of b squared, minus 4 times a times c, and then that's all over 2 times a, or 2 times 1. So that's negative 4 plus or minus the square root of, let's see, that's 16 plus 20, which gives me 36, all over 2. So that's negative 4 plus or minus 6 over 2. So that leads me to negative 4 plus 6 over 2, which is just 2 over 2, or 1, right? And that matches up with this one. The other answer is negative 4 minus 6 over 2, which gives me negative 10 over 2, which is negative 5, which matches up with this answer. All right. Let's try one more of these. Actually, we're going to try two more. What if I had f of x equals, how about x squared minus 5x, how about minus 11? No matter how we try to factor this one, we just cannot find a good way to do that. In which case, the only way we really have right now is with the quadratic formula. So here are my solutions. It'll be a negative b, right? And again, in this case, b is a negative 5. And then that's plus or minus the square root of b squared. So again, that's a negative 5 squared. And then that's minus 4 times a, which again is 1, times c, which is negative 11. Okay. And then that's all over 2 times a. So this looks like it's 5 plus or minus the square root of, let's see, that is 25 plus 44, which gives me 69. Right? All over 2 times a, which, again, if you remember, that should be 2 times 1. So that gives me a 2 down there. Square root of 69 really doesn't factor nice and neat. It's between 8 and 9, but it doesn't come out very cleanly. So let's just leave it like that. So the two answers here are 5 plus the square root of 69 over 2, and 5 minus the square root of 69 over 2. And these are my two solutions. All right. One more example here. If I gave you this, f of x equals, how about 2x squared minus 4x plus 12. Right. We have a couple of ways we could do this. Remember, one thing we could do is I could factor a 2 out and get x squared minus 2x plus 6. And then I could use this part with the quadratic formula. Okay. You can use the original with the quadratic formula, but if you can make it smaller, it's just easier to work with. Right? So here, the answers would be a negative b, so negative 2, plus or minus the square root of b, which is negative 2 squared, minus 4 times a times c, and then that's all over 2 times a, or 2 times 1. Right? So again, I am using the coefficients from this one and not the original one. You can, and you'll get the exact same answers. It's just this one that you use that's smaller will make your square roots and other numbers easier to work with. Right? But by the time you simplify everything, you'll get to the exact same spot. Right? So let's see what we've got here. It's 2 plus or minus the square root of 4 minus 24 all over 2, which is 2 plus or minus the square root of negative 20 over 2. Right? So that negative underneath my radical is giving me issues. Right? That means this is a complex number or an imaginary number, which means I have no real solutions. Right? So this is one of those when we would graph it, it would actually be above my x-axis and it would never come down and cross at any place. Just for a couple other little reminders, if I gave you this one, x squared minus 9x equals 5, you can't use the quadratic formula on this until you bring everything over to one side. Right? And then now we can use that quadratic formula. So it'd be negative 9 plus or minus the square root of, again, b squared minus 4 times a times c all over 2 times a, or 2 times 1. So that's just 9 plus or minus the square root of 81 plus 20, which gives me 9 plus or minus the square root of 101 over 2. Right? So remember, if you're given a quadratic equation like this that's not set equal to 0, set it equal to 0 first, and then you can apply your quadratic formula. Right? So, again, if you're given any kind of a quadratic equation, we have a few different options we can try. Right? We can first try to factor it, right, by pulling out any common terms, and then we can use the quadratic formula if that doesn't work. Right? I always try factoring it first of all because that seems to be easier, but then if I can't factor it, that's when I'll move on to my quadratic formula. Okay? All right, so that is it for now. Right? So we'll be working on these quadratics in class, so I hope you really enjoy them. How could you not? But regardless, if you need any help, come on by and see me, and if not, I will catch you in class. Talk to you later.